Pull Request, live from the heart of Brooklyn. Pull Request is an hour-long podcast about everything in and relating to technology. Starring three techno experts. Eric Newman, hi. Chris Grabowski,
hello.
And Tyler Dinner.
Hey there.
This week's episode, Colonel Sanders. Hello, everybody, and welcome to yet another Pull Request. My name is Eric Newman, and to my left is nobody because we do the show on the internet. But let's pretend today, shall we? So to my left is Chris Grabowski, the most talented back-end, beautiful orchestration,
systems,
infrastructure, cloud
whatever
developer I've ever seen. How are you?
Thank you. I'm doing well, and I just want to say, Mama's not wrong, Colonel Sanders, you're wrong.
That's right, and also I forgot to welcome in our studio audience this week. How are we doing today, studio audience? Yes, that's right, you can see us live do this show nowhere. Anyway, they'll be here to laugh at our funny jokes. That's right. Anyway, how are you doing today, Tyler?
I'm good, thanks. It's been a good weekend.
I forgot to introduce you. There's so much stuff going on,
How
and I cut you off
rude.
during your introduction. That is
How
a double.
rude.
How rude, yes. I'm sorry. Now that we have more intimacy and it's completely silent, how are you?
I'm well, thank you. Did you guys enjoy the nice weekend?
Yeah, it was beautiful out.
Yeah, it was roasting in the rotisserie of New York. We got to marinate in all of that garbage stank as it gets above 80 degrees.
It's great.
I started my morning off with eggs Benny on French toast, so I'm just so happy.
Do you poach the eggs yourself?
No, I had brunch with my parents.
Brunch with your parents. Oh.
Well, I would call it breakfast, but they call it brunch.
Okay.
I don't think 10 a.m. is brunch.
10 to 3 is brunch, yeah. And, I mean, whatever. Meals are a social construct. But would you, I guess, is poaching an egg hard? I never really tried.
I don't know. If it's not fried or scrambled, it's above my head.
Yeah. I've been getting into 2-egg omelets recently.
It depends on the property the eggs live on and whether or not they have good security there.
Well, because I live in gentrified Brooklyn, I'm actually into the cage, not just cage-free, not just free-range, not just organic, no.
Farm
These
table.
are blue eggs.
Ooh.
Blue. They have brown eggs, they have white eggs.
Those come from
These
blue
are-
birds, right?
Means.
Exactly.
Is that how it works?
When they're really young.
Are you getting your protein on?
when they're really young, they inject these hormones into the chicken to make them blue. No, what happens is I don't know actually how the eggs
Are these
end up.
crow
They're
eggs?
probably
Are you eating crow
dyed.
eggs?
No. I mean, that wouldn't be bad though,
Are
right?
you eating Easter eggs?
Well,
Are they left
you'd be
over?
unlocking the fighting power of the crow, so, you know.
No, my powers come from yogurt, actually. Anyway, this has been
That explains so much, dude.
Yes, this has been the Delicious Dish on NPR. Join us next week for no. And I have to stop doing those join us next week jokes. I realize I've done them in like half of our shows, and there's not going to be. It's not funny when every week is a next week.
Next week we'll have Alec Baldwin with his sweaty balls.
Yes. Yes. Anyway, so this week is we're calling it what? Colonel Sanders, and that's because
it has 21. It has a secret recipe of 21 different herbs and spices.
21 different herbs and spices that go
Is it
into
13? How many?
centerpiece of your opera. 12 herbs and spices. I don't
12
think we're
sounds
prepared
familiar.
for this show. Wow. All right.
We
Well,
know nothing about KFC.
we know nothing about the secret recipe for Kentucky Fried Chicken, but we are going to talk about operating system kernels. And that's it.
Close
And the
enough.
differences and stuff about them and what goes into a kernel and what kernels do and why it's not spelt colonel or why that one isn't spelt phonetically. Anyway, but before we get into that, Christian, you added this link about, for conferences of the week, there's DockerCon's kick-ass intro video. What is this?
So, this week, Docker's YouTube put up the video from DockerCon, which happened either last week or the week before. My memory's a little fuzzy on that.
I think it was last week when they announced that they were being changed to Moby.
Yeah, okay, then yes, it was last week. And so just believe it was 2 days ago, they posted day 1, and then yesterday they posted day 2. They're up on YouTube, and the first thing that really hit me there was just they put in just so much effort into this intro that I've really not seen a tech conference kind of do this. It kind of reminds me of watching MTV Music Awards back when those were a thing.
Yeah, no, it's I tried playing a little bit of it. I know it's hard to really get the whole graphics part of it while we're doing an audio program, but they made what looked like an Atari game, a very 8-bit-esque intro, and what is the symbolism here? There are these 4 spaceships shooting somebody.
A squirrel.
Is that what that was? A squirrel?
Yeah, they're containerizing it.
Oh, squirrel barbecue. Okay. Con. What does it say? Con whatever. I don't need you to do commentary for the video. Yeah, this is a lot of... I know they're trying to purposefully go over and above to be funny, but I think they actually lost sight of the joke and just really...
Oh no! I found
it
hilarious. This was.
I think this is just even too much for a joke. This is just ridiculous.
No, I found it hilarious. I thought it was a great joke.
Okay. Anyway, what came out of the Docker conference other than them changing their name and?
Moby, I'd say, was the big thing of saying you've got all these things under this one umbrella for development, but then. The idea with Moby is, you can build out all those tools that your day-to-day developers use, and really only the people who use the underlying libraries are the ones getting screwed, which there are a decent amount, though, unfortunately.
Yeah, it's a drag. Sorry, I was trying to play Moby's something for that funny joke. Yeah, I don't know. The question that I have is, it seems like every big framework has its own conference these days. How big do you have to be to get your own conference?
Well, Docker's not a framework. It's a...
Why does Docker need its own conference? Couldn't it be at some kind of Nerd Fest 17? I don't know.
Maybe those would be the next music festivals. Instead of all these different conferences, you just go to 12 conferences in one.
They already have these things at South by Southwest.
I was going to say, that's what I thought what South by Southwest was, but... why does I just don't get it. Why does Docker need its own? Why does Facebook need its own conference? Is it just?
So the Facebook one is a bit more that's kind of taking a page out of Apple's whole thing of hey, here's what we're doing.
Yes, and I know they're trying to be Apple in the same way that Microsoft tries to be Apple.
The Docker one is a little bit like that, but it's more of a focus on the fact that it is its own technology. There's an ecosystem around it. I think when something evolves from becoming a single program into an entire ecosystem, that's when it kind of warrants a conference, as opposed to hey, I wrote a program, I'm going to have a conference now. That doesn't work. It's, hey, I've got this whole ecosystem. Multiple developers are using this series of tools that are built around. It could have started from one program, but it evolved into a series of tools and this just mentality and this way of doing things. And that's when I think it does warrant a conference. You have a lot of like-minded individuals within this ecosystem working on these things or using these things, and they get together and discuss that.
But what do you really get out of a conference versus a local meetup or versus some kind of forum or blog post?
A meetup is usually I don't know, anywhere from 2 to 3 hours long in general.
Yeah, no, but what are you really doing at these conferences? You're listening to somebody.
They're kind of like a day-long thing. You got much more of an educational opportunity. Generally speaking, there's going to be just more faces there, which could mean more. Trying to think of the right word. I wouldn't say significant, but more big faces there.
Okay, I have a big head. Does that help me any? No. Say anyway.
Might actually hinder you.
Yeah. Not on the radio.
Thank you, audience. Anyway, can GitHub, are they big enough to have their own conference?
They do. They have what is it? GitHub Universe is the big one.
Oh, so they do have their own conference.
Yeah.
Okay. That's cool. And speaking of GitHub, that means it's time for our GitHub issues of the week.
Although this week I did not do GitHub issues necessarily. I found low-level, almost entirely existing in the kernel vulnerabilities, which the kernel is hosted on GitHub, but does not have its issues on GitHub.
Okay, our GitHub issues of the week won't be from GitHub. Landed on thick with the sound effects. Okay, first one is a, I think it's CVE 2016-10-2229. This is from the Computer Security Resource Center and the National Vulnerability Database. This is UDP.C in the Linux kernel. Before 4.5 allows attackers to execute arbitrary code via UDP traffic that triggers an unsafe second checksum calculation during the execution of a received RECV system call with the message peak flag. What is this?
Essentially, you can do a remote execution from sending UDP traffic to a computer for Linux systems running kernels older than 4.5, which a lot of distros aren't on tip, so there's still the case that a lot of them are running prior to 4.5.
Aren't on what? Sorry?
Kernel version 4.5.
No, you said most
Distros
aren't on
kernels
tip?
as new as 4.5.
Oh, I thought you said something else. Anyway, okay. And what is the newest Linux kernel? Is it 4.5?
That's a good question offhand.
Doing an episode on kernels, don't know the newest Linux kernel.
They
version.
release pretty regularly, so, you know.
So do I, but I can tell you my latest version now.
Well, 4.4 is the latest LTS. I know that.
So then...
And I think they're on 4.10. I think they're on 4.10 now, though.
Gotcha. Okay. Yeah. Now, when you go to update, and we might, I don't know, if you want to tease this for later, that's fine. When you go to update a Linux kernel, is that something that you could just do, like, when you go to update the rest of the operating system, or is there a special thing that has to happen?
Depends on your distro. Like, if you're running Ubuntu, you can run an apt-get upgrade-y, and if there is an update for the kernel in the main Ubuntu repository, you will upgrade your kernel.
But why... what's special about Ubuntu over any other Debian that you would use apt-get?
Debian, same thing. Same thing with like RHEL, CentOS, Fedora.
So most of them.
Some of the ones where they pride themselves in giving the developer more control, like an Arch or a Gentoo, that's a bit more. You have to go a little bit more out of your way to do so.
Interesting. Is it really a complex process that these more mature distributions have automated, or is it just something that the other random guys, the also-rans, haven't picked up on?
It's really just a matter of preference. Some of these some of these distros, they want to give the developer full control, so it's up to them to do it, as opposed to these ones that are used in more of these enterprise situations where it's a bit more managed by the companies, where they have official forks of the kernel, which are usually just patches that eventually get submitted upstream. Sometimes they are using the actual upstream kernel, depending on the distro. Like CoreOS is very adamant about running the actual Linux kernel. Anything they make into the patch to make sure any patches they make into their kernel, they make sure it gets into the actual Linux kernel.
Interesting. But I understand wanting to give developers more control, and I also understand wanting to have more of a managed environment in an enterprise. But we're just talking about a command that runs something that isn't being... we're not forcing... It's not like Windows. It's not forcing your computer to upgrade. But wouldn't it be nice if you wanted to automatically upgrade your stuff? I don't know.
Well, sure, yeah. If you want to set up auto updates, that's quite possible.
But not in one of these distributions that doesn't auto update the kernel, or it doesn't allow you to auto update.
Well, you could do that yourself. You set up a cron to do so. I mean, anything could be croned.
That's true.
Or just set up at boot, check if there's a new kernel version. If so, upgrade the kernel.
But I thought that you said upgrading the kernel was an involved process unless it's done by one of these.
No, I didn't say it was involved. I just said it was manual.
Oh. How manual is it? Sorry, well, how involved is it?
You'd have to see, is there a new kernel available? If so, depending on the distro, is there a precompiled one for this distro, or do I have to build one from source? And then from there, depending on your OS, do you do some little magic partition swapping stuff, or do you just say, hey, load up all these kernel modules, and then anything that needs a reboot, either say, hey, I need a reboot, or wait until I can reboot to load up the other modules that can't be loaded up dynamically, which these days there's very few that can't be loaded dynamically.
Let's go back to this magic partition swapping stuff that you mentioned briefly. What is that? Does that allow you to basically hot reload a kernel while the computer is still on? Or?
It's more like a full distro upgrade that I'm thinking of. where I get this from is CoreOS does this to do their auto update, and it'll let you say, hey, partition A is running right now, that's the one that's booted, write all the updates to partition B, swap them out. It's also, it's taken from Chrome OS, was the original one to do this, Google's Chromebooks, and it would run this protocol code Omaha and pull all the updates it needs, and then swap these partitions. Thanks to the virtual file system, it would be bootless.
Bootless? Huh.
Well, I should say it doesn't need a reboot, is what I meant.
But, I mean, aren't there things that might require... Whatever, we're getting off track. Anyway, to the next, not GitHub vulnerability of the week. Okay, 2017-8305. This is from the same place as the other one. The UDF client before 0.8.8. Well, that's your problem using beta software now. UDF, not UDP. Before 0.8.8, custom string L or an I? String L copy implementation has a buffer overflow. UDF client string L copy is only used on systems with the C library, like glibc, that lacks its own strl copy. What is the L? Long?
Yeah.
Why does a long string need a
separate
separate
function? No, it's not. L is it's a special syscall. Trying to remember.
What is it? The audience isn't liking this.
No.
Oh, sorry.
Trying to remember.
Anyway, so it has a buffer overflow. Size-bounded string copying concatenation, or inconcatenation. So it's size-bound. You have your restricted size. That's the... yeah. So,
next.
This has... Yeah, exactly. Thank you, Tyler. Next, that has a buffer overflow exploit. And what happens if you pass in a maliciously coded string, you can get it to, I'm sure, do stuff in your computer.
That's like Facebook and MySpace stuff. Next.
All right.
Backdoor.
2017-7720.
Webcam backdoor. There's probably a lot of videos with that title on the internet right now.
There's a giggity on the notes
There's webcam backdoors and backdoor webcams. Those are not the same thing. CVE 2017, let's press on. 7720, buffer overflow, another buffer overflow in private tunnel 2.7 and 2.8 that allows local attackers to cause a denial of service, SEH overwrite, or possibly have unspecified or other impact via a long password. What is private tunnel?
It is a form of VPN.
Okay.
Yep.
And
that uses the TUN device in Linux to be able to provide this private connection.
Interesting. And so there's just a buffer overflow vulnerability? Mm-hmm. What is an SEH overwrite?
Trying to remember. I remember SEH is structured exception handler.
So that gets overwritten. Next.
I think that's all of the webcam backdoor. I don't know why that one didn't.
That could have been so much better.
I know. All right. 2017-8224. Wireless IP camera, Wi-Fi cam devices have a backdoor root account that can be accessed with Telnet. And that sounds pretty self-explanatory. If you're using one of these wireless IP-based cameras, chances are there's a default password that probably is never reset, or a type of authentication that really sucks and then can be easily bypassed.
Well, clearly we should test it out just to make sure that they patched the fix.
Well, no, it's probably that they...
Make sure they covered the back door. Is that what you're saying?
Yeah.
That means two things.
Yeah.
We're doing the right thing.
This is for the good of all mankind here.
They did not properly test their back door.
We have to save the world.
Gotta press on that back door.
Yeah, that's another good one.
That one is also sexual.
Yeah, that was, I don't know what your audience is doing there, Eric.
There's a mirror behind us, and so they can only, they're in an isolated room. That's how we're picking them up.
You gave them a bunch of wine before the show so that they'd laugh more, and then now they've just started.
I don't think so. Did I give you guys a bunch of wine before the show, everybody? Okay, maybe I did. All right, anyway.
Did I hear, like, change dropping the floor during that?
Oh, that was...
That's the pull request after dark. Anyway. When the lights go out, but the podcast keeps rolling. It's never mind.
Yes.
Yes. So, there's not really a nice... easy transition into the big news story for this week. Though I think we all got a kick out of the whole news story, the whole episode of news that we did last week. Even though there are other technology podcasts, and even though they do talk about news, and even though some of the stories that we talked about were a little, let's say, not so fresh, I think that we were able to add, I don't know, a nice bit of insight into them. And you don't have to listen
I'd say
to...
so.
Yeah, don't listen to the other tech podcasts. You can just keep your device, your phone or radio device, tuned to pull request. The sultry sounds of our voices.
We're basically like last week tonight of pull request. You don't have to listen to all the other stuff. You just listen to us, and then you and all your friends can be sure that you know what's going on.
Exactly. And this...
Sorry,
this
none
week,
of us have an exaggerated British accent, though.
We need a British guy.
We do need a British
it's
guy.
not an exaggerated British accent. If anything, it's been
Eric, if you're
watered
not sitting
down.
down, you might want to sit down. We're replacing you with some British guy.
Some British guy.
I know a guy that can do a Scottish accent. Was that close enough?
Nah, it's not good for a whole half an hour. Anyway.
Yeah, that gets old after 5
Is it
minutes.
offensive if he's not Scottish?
Yes.
Wait,
anyway.
Do I know him? I feel like I know him.
Oh, yeah.
Yeah, okay, yeah.
Anyway, did you know that on phones, there may be apps that have ports that they leave open and that aren't entirely secured? Which means, much like some of the exploits that we've already talked about and vulnerabilities that we've talked about, that they are rife for exploit. It was a bad word choice. But leaving open ports is something that is nothing new, but a group of security researchers, also undergraduate computer science students, at the University of Michigan have found some startling news. I need a cup of coffee or something. Have found some startling news about Android applications. Let's hear it from our news department. Newman presents News to Use. Ann Arbor, Michigan. Computer science researchers from the University of Michigan and Ann Arbor have found that hundreds of Android applications found on the Google Play Store have security holes that may allow attackers to steal your data and potentially infect your smartphone with malware. They developed a unique application analyzer called OP Analyzer and assessed how each type of Android application utilizes the network, breaking them down into 5 distinct categories. After analyzing over 100,000 Android applications, they identified 410 of them as vulnerable, with up to 956 potential exploits. They manually confirmed the vulnerabilities for 57 applications, some very popular with up to 10 to 50 million downloads. What does this mean for computer security going forward? Only time will tell. And so many Americans are afraid of what happens next. At least now the world still turns and the truth marches on. And that's why this has been News to Use. Brought to you by Pneumonium. 100,000 applications analyzed.
I'm not surprised, honestly.
But, well, hold on. Here's what's interesting in the sensationalism of this news article. 100,000 Android applications analyzed, but 410 of them were found to be vulnerable. That's a pretty good slice. I'm sorry, that's pretty good odds. That's fewer than 1%.
Oh yeah,
That's
sure.
so
but
random.
It's fewer.
I'm not at all
That's
surprised.
0.4%.
If I had to guess, they picked some like no-name developer ones that were like, "Hey, why is port 3004 open?"
Right? Why is port 8008 open? Oh. I'll wait
Actually,
for Tyler to get that joke. Anyway, no.
There is
I'm thinking about it.
80,085 is also valid.
And
That means two things.
You guys are doing calculator jokes.
Yes.
Yeah.
They said that, yeah, I'm sure some of them were no-name apps, and I'm sure some of them were, apps that their friends made. But it said some of them were, big applications with 10 to 50 million downloads, so they probably threw into Facebook or a YouTube
I think a lot of people
Grindr.
forget that Android is just another. Okay, so it's Linux-based.
It's
not
basically
full-on
Windows.
Linux.
It's basically
No,
no.
It's
I know that it's Linux based. I understand that. I'm saying metaphorically, the way that Windows is to the PC space, Android is to the mobile space. It's not number one, but they say that you
population-wise, market share.
Okay, just like Windows has the
Yeah.
most. It's on the most amount of different makes and has the widest geographical use. When I say number one, I mean best, because you can't beat Mac OS. I wish
That's
somebody
debatable for
would,
mobile.
because it's not doing so well, but,
And Linux, aside from the fact that my desktop flickers when I'm on Hangouts, I would say has beat Mac OS. In my opinion, I honestly like my work laptop much better than my
except
MacBook
that I
at
have
this
to
point.
literally hold the wires that keep my computer together. The Linux is great.
It's just Hangouts flickers. Other than that, I upgraded to the latest kernel I could get, and I've been happy ever since.
Yeah, and you could build your own car too, but is that the best way to go? I don't know.
Honestly, if I got like a kit car, that'd be awesome. Have you seen
And
those
that's
things?
and that's exactly what Linux is. It's like a kit car that you could build on
Yeah.
your own. Windows is like a giant Hummer that you want, but then realize it's a giant mistake after you buy it. But then, it's the biggest thing on the road, so screw everybody
it's
else.
more like the moped. Nobody wants to see you on that. But
Whatever
I'll get
you
you from
do,
point A to point
whatever
B.
you do not buy your own. Do not build your own plane. Do not. That's just
Not yet.
no.
They should do that on
no.
Top Gear.
John
Anyway.
Denver tried that. It did not turn out good. It's not good.
Yes.
We lose good people when they try to build their own planes.
Anyway, my point of that Android is the Windows of smartphones is when you look at the way that it's being used, the type of people that are using it, and when I say way that it's being used, it's also a way that allows you to have more control and more customization over your device, and has fewer restrictions on what you can put on it. That's why you can put almost anything on the Google Play Store, and if it won't get on the Google Play Store, then you can figure out how to sideload it onto your phone.
That's not true.
I said almost.
No, actually, getting on Google Play Store, it's from a front-end perspective, I'd say it's less strict than iOS, where it's like you have to follow their style guide and everything. But from a systems perspective, if anything, it's more strict because it's the fact that a lot of the security features in Android are just Linux features, and if you're a developer who's trying to do malicious things, you're probably on Linux, so you know this kind of stuff.
Right, but I mean, whatever. It's fine. I think I'm losing my mind. No. Sorry, I've got a lot of tabs open, trying to move a bunch of stuff around. Anyway, 100. So with the I'm losing it, Christian. I think that's all that we have to talk about for the app stuff, the Android app stuff.
I would agree,
because open ports. If your application is using a port, whether it's a desktop application or it's a mobile application, please make sure that you're using your internet connection or your network device judiciously. If these applications have an open port, now, I mean, is that really the application's problem? Is that something that the operating system really should be managing? Because it's, it is kind of just a heavily abstracted API call to get something. Where is this irresponsibility taking place along the stack? Do you know, Christian?
You're saying these open ports?
Yeah. Because it's
well,
not. I mean,
it's so I'd say it's the open ports are being used by the developers, but it really should be like.
But you're not saying to maybe you are saying to open this port and just listen for connections forever. But I mean that's something that would typically be abstracted
but
somewhere.
That's something that I would also say really. A part of it is on really any Unix-based system. You say, "Hey, I want to listen to this high number port." Any user can do high number ports, so that's actually low number ports that it can't. But I think
I know that. But what I'm saying is, doesn't the operating system step in after a while and say, "Okay, let's close up shop"? I guess not.
No.
But okay. Well, what type of?
I would say. As part of like the checklist to get into these stores, maybe you'd be like, "Hey, I'm using these protocols, or even a custom one, and it needs to this port." If the port, and I would say that port should be one that does normally run over root, but it should be one that, hey, we're using TLS. There should be a checklist that like, if you are running an open port, it should be one of these ports. It should be a known protocol, or you should have to be able to submit documentation on your protocol to getting through the store. I think is like really the only way to handle it if you're doing this Unix-based way of doing networking, which is how all the mobile phones out there are Unix-based. You got iOS, or you got Android. Both of them are still using the Unix ports design there, and so these high number user ports, if anything, are a bit more detrimental. The other thing you could do though is give like an application manifest with your app that basically sets IP table rules when you install your app.
I mean, you do have to give some kind of manifest when you submit it to the store anyway.
Exactly. That's what I'm saying. Maybe you could include IP table rules in this to say
that would not be a bad idea. But then, so what happened?
On this port, only talk to this domain, or which would have to be an IP, which then would have to be dynamic, unfortunately, unless you do have some kind of static IP.
But even if it's a static IP, as we said in an earlier,
maybe Android needs some higher level construct to say, do DNS resolution regularly to say, let me check what that IP address is, now update those IP table rules. So that way you can give a domain name and just say, hey, periodically let me update DNS there and say, okay, now switch these IP table rules to allow this IP address.
But you're saying to validate that only when the app is being approved. So if that changes...
No. I'm saying in use, using the IP table rules. All of a
that
sudden
would make sense. That would make sense, but what about fudging? Would that prevent?
You mean spoofing the IP address?
Spoofing, yes. Wouldn't that prevent, or would that prevent spoofing the IP address?
No. Well, depending. If you're doing TCP, good luck. If you're doing UDP, honestly, I'd be kind of curious. Aside from DNS, why you'd be using UDP on a phone?
Yeah, I don't know.
But well, calls. That's about it. Like DNS and VoIP is actually over UDP.
Right. So if we had some kind of voice calling app, and I said, let's open these ports for this transmission.
Well, that's a standardized protocol, though. That it should be, hey, we're using it over this port.
And it never yeah. So what is it? It's just like it's opening a port and then never closes it, and then also has a really bad way of interpreting the data that it receives.
Well, think of it from like a regular server perspective. You have a server running some process, and it's like a app that you had, and you nmap it, and you're like, hey, why is port 8080 open? And you look, and it's like, oh, that's that application, and it's listening on any instead of the private IP. Sorry, it's bound to any IP as opposed to the private IP, I should say.
Okay.
It's listening on 8080 no matter what. But the IP address that it's bound to would be 0.0.0.0.
Anyway.
I think I added an extra 0. But, yeah.
What was your point?
That's basically what you're doing here is, hey, you've got an application running, it's on this port, and it's kind of just exposed to the world. Your phone, if it's not connected to Wi-Fi, it just has the public IP that is the one that you're using for your data plan.
Yeah, but there's no way that your phone is connected directly to the internet. It's got to be behind your carrier's giant router or something like that. There's no way.
But who else is on that though?
A lot of people.
Yeah.
But they can't find my phone's IP address because that's
You'd be surprised. And also, if you're on local Wi-Fi, it's even easier. In fact, it's very easy to say, let me get all the IP addresses off of my router here that I'm connected to.
Is 107 that's not a protected IP range, right? No, I guess that is a real... Oh, it wouldn't be able to tell me that. Never mind. Anyway, right, so I guess our advice to wonderful app developers everywhere is, if you open a port, please remember to close it when you are supposed to close it.
I wouldn't say that's the right advice.
No, what's the right advice?
Either
open
use
ports?
use the right port for your protocols. If you're doing HTTP 80 and 443, more so just 443 if anything. In fact, I think if you're doing HTTP, it does have to be HTTPS now on mobile devices. And if you're doing other protocols, then I'd suggest that you handle it the same way. And I do think this idea of some dynamic IP table rules, well, it would kill the battery in a sense. Most likely, certain phones you do fine. Certain phones would just die. That would probably be the ultimate way to fix it. Is just, hey, update these IP tables rules and you're good.
Interesting. Here, they made a website for this type of attack. It says, vulnerable open port apps put device, not the device, under the threat of network attackers. Attacker can first scan his local network or even public IP addresses in the internet to discover hosts, and then use the MAC address database to identify mobile devices. Once reachable mobile devices are selected, the attacker sends traffic to the port that belongs to the certain vulnerable app on these hosts, and vulnerabilities are exploited if vulnerable apps are running on those running on those devices. For ethical concern, we only demonstrate the attack in the local network using our ARP scan to discover victims. Note the attacker can also use some tools as ZMAP to discover victims on the internet scale. And this video that they have is showing how you can steal someone's photos over the network using an open port. Photos are stolen from an SD card. Yeah, attacker can steal all data from the victim's storage device remotely. Anyway, so secure your stuff is what we're saying. All right. Now to kernels, and we don't have theme music for that.
Should have got some popcorn sound.
No. Oh, right, because of the... I mean, of course, we could do some... we could reuse some NFL music. Just the... Anyway! No, that was actually from the wrong decade.
Is that what you think NFL music is?
It was from the 70s. I meant, sorry. Here. Tonight. I got nothing. I don't actually watch football. It's not. There we go. Anyway,
That is not what you want happening on opening kickoff.
No. So let's get into kernels. Now, kernels are the centerpiece of any operating system, and every operating system has them. There are different types of kernels, and they manage everything. I guess that's the best way to put it. Anything, any service, any sort of device on your computer, any service that is run by your computer eventually has to talk to the kernel. It acts as an interface between user applications and hardware. The sole aim of the kernel is to manage the communication between the software and the hardware. The main tasks of the kernel are process management, device management, memory management, interrupt handling, I/O communication, file system management, etc.
I hate
Is the
management.
Linux kernel... Is Linux a kernel or an operating system? Well, they're
Linux,
actually...
Well, a kernel is an operating system.
A kernel is an operating system.
Well, I should say it is the bulk of an operating system. There are things built around it that give you... I think operating system is actually the more loosely used word than Linux here, if anything. I'd say Linux, the kernel, there's distros built around it, and then the loosely used word here is operating system, where some people call the operating system what the distro is, some people call the operating system what the kernel is.
Interesting. Well, in this case, this website, which is some random website, go4expert.com, but actually has a really nice article about this, says, basically an operating system is a kernel space and a user space. So I could see where it would just be the kernel because that does all the basic stuff for the operating system, but you do need your user space where all the stuff where all your stuff happens.
Your user space is managed by the kernel, though.
Everything is managed by the kernel.
Exactly.
Is art design? Anyway, there are two types of kernels: monolithic kernels and microkernels. I feel like there's a third one, but maybe not.
Well, there is now, but it's so that's.
Well, let's start with a monolith.
All right, but I do want to just say the name of the third one. Which
what is the third one?
It's called the unikernel.
I knew that's what it was. Yeah.
Which is the idea of actually compiling the kernel into your application. So that way your application runs with just parts of the kernel that it needs, and all you're running is your application as opposed to this whole operating system or distro, however you want to view it, around it.
But then you're kind of copying the kernel into all of the apps. So then aren't the apps bigger?
This is more for like one of the classic uses is a IoT device where all it needs to do is have one specific function.
Okay, let's get back to that. Because I didn't want to mention unikernel because then I knew that it would go into this rat hole anyway. Monolithic kernels. Earlier in this type of kernel architecture, all the basic system services like process and memory management, interrupt handling, etc., were packaged into a single module in kernel space. This type of architecture led to some serious drawbacks, like the size of the kernel, which was huge, poor maintainability, which means bug fixing or the addition of new features resulting in recompilation of the whole kernel, and that can consume hours. In a modern-day approach to monolithic architecture, the kernel consists of different modules which can be dynamically loaded and then unloaded. This modular approach allows an easy extension of the OS's capabilities. With this approach, maintainability of the kernel became very easy as only the concerned module needed to be unloaded and reloaded every time there is a change or bug fix. So, there's no need to recompile everything. Linux kernel follows the modular monolithic approach. Would you agree?
Yes.
Okay. Microkernels. This architecture majorly caters to the problem of ever-growing kernels, or the ever-growing size of kernel code, which we could not control in the monolithic approach. This architecture allows some basic services like device driver management, protocol stack, file system, etc., to run in user space. This reduces the kernel size and also increases the security and stability of the OS, as we have the bare minimum code running in the kernel. So
I do want to say, your favorite operating system wants to line between the two of these.
Wait, hold on. So if a basic service like networking crashes, it won't bring down the whole computer, which was definitely a problem of many versions of Windows and old versions of Mac OS.
Well, I'd say these days that's the case for even some of the monolithic kernel architectures where you can still isolate it. It's just a matter of the architecture itself is different. And what I will say is current OS X is actually kind of walks the line between the two of these, where you have the monolith being Darwin, and then you have the proprietary OS X stuff being brought in that actually functions more like the microkernel architecture.
Interesting. But Darwin is still, while it's open source, it's still very much Apple.
Yeah, it's still just within Apple. In fact, Darwin is a combination of the BSD kernel plus parts known as the Mach kernel.
MACH, which is what?
Just the word Mach itself, but that.
I meant the Mach kernel.
What do you mean? It's which is what it handles the low level things like device drivers, the I/O management. Some of the process scheduling, depending on what we're talking about. If you're talking task scheduling, that's usually handled by BSD there. But some of these
so it's just called Mach because it's fast. I guess that's what I was getting at.
Okay.
That was a question? Yes. Is that?
I honestly don't know the origin of the name.
I should have looked that up anyway. So there are many parts. There are many things, and we've listed them, or most of them, a couple times. That kernels deal with, like boot processes and schedulers and tasks. And is a scheduler part of a kernel?
Yes. It doesn't
memory
have to be.
Management is that part of the kernel?
Yes, that is.
All right.
That does
file
have to be.
system management, logical volume managers, namespaces, C groups, protection rings or capabilities, access control lists. All this type of stuff is managed by your particular kernel.
Yes.
Now, all distributions of Linux, do they use the same kernel? How does that work?
They use either a fork of the kernel or the actual kernel, different versions of the kernel.
So even though these vastly different versions of Linux, like BSD versus...
Whoa. BSD is not Linux.
Oh, Unix, sorry. So that was actually getting to my question. So where does is there a single source of truth for all kernels in the Unix environment, or is it only Linux kernels are kind of shared, Unix kernels do their own thing, or what is it?
So it is Linux. It's based off of Unix in design, but it's not a Unix kernel. It did not start from Unix. and a lot of the design principles came from Unix, though, and Unix itself, you had what were called true Unix OSs, which there is the actual Unix, then there is BSD, there's still a bunch of different open source variations of BSD. Solaris is considered a true Unix operating system.
Okay, so my point of, does BSD start with the same kernel that Solaris starts with, and then they adapt the changes to their distribution? I know they're not Linux, and I know you said specifically Linux, but that's why I'm asking. In the Unix world, do they share that at all? Or are there... What is it?
They share bits and pieces.
Are there guidelines that come from, like, the group? They're like, we want to do this in the next version of the Unix kernel, and then everybody agrees to do
Unix,
it, or what is...
There's no active development on the Unix kernel.
Okay, so who figures out how does the Unix kernel? There is no Unix kernel as a singular entity. I guess it's kind of a intangible thing.
It was Unix as a singular entity was a research project that is no longer in existence.
70s, 60s.
Yes.
Yeah. Okay. So if BSD wants to update their kernel and Sun wants to update their kernel, they do that completely autonomously.
Sun, it's Oracle now that says
Solaris, which stuck in the 2000s.
Is EOL, and it's now FreeBSD, OpenBSD, NetBSD, but BSD itself I don't think is actively being worked on.
You're taking the semantics are kind of eschewing my question. My question is, are they completely separate? They don't talk to each other. There's no relationship between the two.
There's shared logic, there's shared modules, but in itself they are separate development.
Okay. Is that true for the Linux world?
Linux is independent of all these. They can share ideas, but the code itself is the Linux kernel code.
And does that come from the Linux Foundation? Does it come from like some centralized place that everybody adapts, or do they all agree on...
It's open source, so just any one person who has code that gets accepted into the Linux kernel can develop on it.
Okay. Is there a GitHub repo for the Linux kernel?
There is. It's Torvalds/Linux.
Oh man, that's really funny. That's I need to see. The problem with my audience is that I have a problem giving them signals. So I forgot that the funny signal is this one. It's yeah. Anyway, sorry. Okay, I'm not gonna. I'll tell them to go home. All right. So, how do all of these people agree on what to implement on the next Linux kernel?
Through mailing lists is a big part of it, and then pull requests. He said it.
He said it.
Okay, so they are collaborating, and then they just kind of collectively decide on what to do and implement it for the various distributions that they have.
Yep.
Now let's see. You have a lot of topics listed on here, a lot of attributes, I should say, of kernels listed on here. How exactly do you want to dive into them? How do you want to talk about the Linux startup process?
The boot process is one I can just give a general overview of like how it works.
Okay, so the kernel manages the boot process?
Well, no, it's part of the boot process. The boot process itself is you hit you supply power to the computer somehow, whether it's wake on LAN, hitting a power button, plugging it directly in, something like that, which then goes through a series of hardware switches to actually turn that straight power into logic, which then will initiate the BIOS. The BIOS being either your plain BIOS or a UEFI BIOS. And those can vary from the UEFI BIOS is essentially its own standalone operating system with its own internal bootloader and all sorts of things in that nature. Or a traditional BIOS is just a simple algorithm that either way the goal is to just load your bootloader, which in the case of Linux there's a few, but you're most likely going to be loading in grub.
You also left out, by the way, an important part of the BIOS, which is the power on self-test, or post. It's not really called post anymore,
true.
But all modern computers will yell at you if they have a problem. Macintoshes have some kind of chime that they say when they're unhappy, and other computers will just beep. But yes, that is an important part of the process because you can't get to the bootloader if your components don't start or if the components aren't working.
Yep. And so that loads grub traditionally in Linux, or most commonly, I should say. And then from grub, that'll actually, like if you get to the grub window, it says, hey, you're running multiple Linux distros, which one do you want to boot into? Or it'll just actually load your one Linux distro if you have it, or one operating system. You can load Windows from grub, actually.
Now, here's a question. In order, BIOSes have to have some kind of cursory knowledge of the devices and the device drivers.
Mm-hmm.
That seems to be a relatively new construct because it was a real task in the late 90s to get your computer to boot from a CD drive. It was an even bigger task a few years later to get your computer to boot from a flash drive. It still kind of is now.
Sure.
Older
Generally,
Macintoshes can't boot from USB. So what is it that allowed?
There's usually an embedded common driver that is not a full-featured driver for the device, but a simple enough one for the BIOS to use it.
Like for Wake on LAN, it just needs a little something for the Ethernet card. It doesn't need the whole feature set.
That's a little more of an advanced one that can be particular. But for, say, like a CD-ROM or a RAID card, for instance, those are a bit different where you do have this very basic driver that it's just actually loaded into the firmware itself that works for the BIOS level.
Gotcha.
And so from the bootloader, it'll actually start initiating the boot process itself, which will start out with, at the kernel phase, which first thing is actually loading the kernel. So there's the base kernel binary, which then loads its dynamically linked modules. And once those are all loaded, it'll have its drivers and the core logic of the kernel itself, and then it begins its startup phase, which is generally calling the init ramfs, which that exists as it creates a RAM disk in memory, and that is there to actually mount your rootfs.
So this is really building complexity from simplicity, where everything kind of bootstraps a slightly bigger thing onto it, which then bootstraps another slightly bigger thing onto that, and through all these handoffs you get into a big kernel, into a giant file system, into a real operating system. But you start with like a really small bootloader, that you have to really small. Is it so? It does load the kernel first. Is that what it does, or what is it?
Yep.
It loads the kernel first, but then that loads something else that loads like a bigger kernel?
Well, you have an init ramfs, which can be just a shell script that's embedded into the kernel itself.
Why do that? That seems so unnecessary.
You have to. There's really no other way to do it. There was init ram disk prior to that, but all it is saying, hey, I've got this fake rootfs that exists entirely in memory. In the Linux world, it's usually embed busybox, and then here's all this stuff that I can use with it. And then Chorus, for instance, took it a step further and said embed this Go binary that replaces that, and along with that, this JSON file that you define, and tell me how I want to have my rootfs look.
Interesting. So it's a bootstrapping file system essentially before it loads your real file system.
Yes.
Interesting.
And then with the init ramfs, it'll boot your, it'll mount whatever actual file system you have on disk, whether it's XFS, ButterFS, ZFS, ext4FS, anything that supports Linux in this particular situation that I'm describing. And then that'll actually be mounted into the virtual file system, which is part of the kernel. And once the init ramfs is completed, there is a kexec called tupid1, which is your init system. And so there's
all right. Let's take a step back because I think you almost lost me.
Breathe.
Okay, so Christian's going to turn this podcast into something that boots a computer. Okay, so let's. I don't even know exactly where to go back. All right, so we have the bootloader loads the kernel, loads a very rudimentary file system as a RAM disk. That figures out the more complex file system that you have and some more complex services to start. and then
No,
loads those
inner
and
manifest
starts
just says, I need to run this series of commands to load up my root file system, and once I complete, the kernel will then execute your init system.
Okay, and then
Pick one.
and then the kernel, everything it executes then goes through the kernel's scheduler. Right?
Correct. All execution is managed in the kernel scheduler.
But that's not
is
actually. But
saying,
that doesn't come up until after the RAM disk is done.
Right.
Okay.
So that's still being managed by the kernel itself. It's just saying, that's usually done in series, so it's not dealing with any concurrency. So it's pretty simple to say, just run these processes in series, and then once that completes, then I have an actual process to create, as opposed to there are processes technically running in the kernel, and the kernel does schedule these. And kexec says, I need to execute this process with special privileges, which is PID1. PID1 has the special privileges that other processes do not have.
Gotcha. And now let's save the privilege capability security stuff for a little further on. But okay, scheduling. So there are different types of schedulers, and there's the completely fair scheduler. Is that the most used one, the most popular one right now, or
it's not that it's the most popular. It is the default scheduler within Linux.
Okay. And when you talk about multitasking and you talk about time-based multitasking or preemptive multitasking, that's all handled by the scheduler.
Correct.
Okay. So the completely fair scheduler is a process schedule which was merged into the 2.6.23, that's October 2007 for those of you at home, release of the Linux kernel, and is the default scheduler. I can't say that word right. Look at that. It handles CPU resource allocation for executing processes, aims to maximize overall CPU utilization while also maximizing interactive performance. What is fair scheduling?
So fair scheduling is the idea of you have a queue, which in this particular case is represented with a red-black tree, which is a type of binary tree that uses what's known as the red-black algorithm to balance it. And then for each process that gets scheduled onto a CPU core, it is the size of the queue divided by the time it was the process was waiting. Is
so
the
all
amount of time
processes have an equal
Sorry, the time that the process was waiting divided by the size of the queue, I should say, is the amount of time that the process gets to run on that particular core.
Right, but it's a very fair division, so all the processes get equal time.
Right.
Okay.
Roughly. In an ideal world,
right.
Yes.
In contrast to the previous Order 1 scheduler used in older Linux kernels, the CFS scheduler implementation is not based on run queues. Oh, sorry, Christian. Instead, you said red-black tree. Implements a timeline of future task execution. What's a red-black tree? I should know this. It's not a binary tree, is it? Oh, it is. It is a self-balancing binary search
that uses the red-black algorithm to balance itself.
Balances itself. Oh, extra bit. Each node of the binary tree has an extra bit, and that bit is often interpreted as the color, red or black, of the node. Interesting. Yep. So you balance it based on basically like a parity bit. And, all right. So the previous scheduler, before the completely fair scheduler, just had a queue of things to run, and you just added stuff to the queue, and it pulled it off?
Yep. Pretty much.
Okay. Like the old O1s, and then in that case, then any task would take as long as it was supposed to take until it's done, which could eat up your whole system.
Well, prior to that, too, multitasking wasn't such a thing. It wasn't so much of a thing. So if you did have long-running processes, it would generally be not the scheduler's job, but say that there is a max time within the kernel, or you yourself told the process to sleep.
Yes, and I am not a fan of multitasking. That's why I use the Simple Finder. And actually, there was a Simple Finder that only allowed you to do a few things on macOS. Anyway, like the run queue-based scheduler, CFS uses a concept called sleeper fairness, which considers sleeping or waiting tasks equivalent to those on the run queue. This means that interactive tasks which spend most of their time waiting for the user input or other events get a comparable share of the CPU time when they need it. Which considers sleeping or waking tasks So if it's waiting for a keyboard, then the scheduler will put it to sleep. But then will it give the time back that it took when it wakes it up? Is that what that is?
Essentially, yes.
Okay. So we're saying your
good
slice
example is
wait. You're saying your slice program A, your slice is 5 seconds, and I see that you want a keyboard input, so we're going to let you run for 4 seconds. But then when you wake up, we'll give you that extra time back.
Except then you get into details like, is this a blocking syscall, or are you doing event-based I/O there to actually say only on the event that the key is pressed, then wake the process up, because there are certain syscalls where you say just wait and be on the processor the entire time that you're waiting.
Gotcha. All right. So that's scheduling. Let's see. Scheduling threads and processes. I don't think we've ever. We talk about this all the time, but I don't think we've ever really kind of differentiated between them. What is a thread versus what is a process?
So I think the best way to look at this is through the old equilateral.
Is it a square or a rectangle?
Hold up, I'm getting to it.
No.
The equilateral diagram where you have tasks, think of that as the equilateral, and then threads are the rhombus and processes are the rectangle. And with that, the threads are lightweight, and they're very similar to a process, except processes have all the resources recollected when they are done. Threads, on the other hand, it's all manually done by the program itself to actually do this. And thread memory, threads have it's actually essentially the same memory scape, but threads do not have the ability to isolate memory like you can with processes. While you can share process memory, threads by default will always share memory, but processes won't unless you pass in certain flags to say shared memory. And threads that do not get a PID allocated to them in user space, but they are essentially at the core, they are just a task that are being scheduled. So in the scheduler's eye, they just look like anything. They are just these execution contexts that can run independent of each other. But processes also have all these other things built around them that exist in the kernel to clean themselves up. While threads, you need to, in user space, say, release this resource when this thread is done.
Gotcha. And processes can have threads. Threads can't have processes. That's kind of the relationship.
Right.
A thread must have a process to execute.
So the one little semantical gray area there would be the fact that processes can have child processes.
And I was just going to ask, what is the difference between like a child process and a thread?
So a child
other than
process,
how the memory is kind of allocated in that stuff.
Well,
is that actually the difference, though? Is that the only difference?
It depends on if you're using shared memory across processes or not. If you are, then it is very similar. It's a matter of the kernel will still reclaim all the resources being used by the child process as opposed to a thread. But a thread can be within a process managing its child processes, but you don't really have direct control of the child threads that is being handled by the child process.
Gotcha. And what is a POSIX thread? POSIX.
So POSIX is probably the most common API to create threads, because
what
threads
is POSIX?
POSIX is trying to remember what that actually stands for. Like portable operating system interface, and then X because Unix.
Very good. That's exactly what it is.
Awesome.
Very good. Okay.
A+.
What is it?
So it's a API for user space threading that because it's under the hood actually using the clone syscall, and then POSIX also has all these other things around it to say allocate the certain amount of memory in the page tables and yada yada yada. But now it's essentially it's just to do it. There's no real definitive way to create a thread. So POSIX is a standardized API to say, here is a way to create a thread. as opposed to doing this much lower level. I need because normally you're saying I just need a execution context, and it is a thread because it's in user space, and I have this much memory, and POSIX manages to wrap that into like several functions.
Gotcha. Okay, so we've talked about boot process, schedulers, tasks, virtual memory. Is that like virtual reality?
No,
it's not.
So you have your physical memory, which are your I don't know, like in my MacBook Pro, I have 16 gigs of physical memory. But virtual memory, you have virtually endless amounts of memory.
And where is that memory stored?
That's done through page tables in the kernel, which
and
are
that
the
is
idea
stored
of.
Where?
This is it is stored in memory
on the disk.
On the what?
Stored on it. Virtual memory is stored on a disk. Isn't it?
No.
No?
You're thinking of swap.
I thought that was virtual memory.
No, virtual memory is the idea of multiplexing physical memory. You're thinking
no,
of
but
swap.
I thought it was like when you run out of physical memory, then you could use this.
That's swap.
Not on Windows.
No, it is.
Since
Virtual
when do you
memory
know about
itself
Windows,
Eric? Virtual memory is the kernel saying I have this a physical address space that maps to all of these virtual address spaces, and then in user space you're using these virtual address spaces.
So then, why have virtual memory?
So that way you have much more memory to be able to be used by your processes. Otherwise, you're only running 16 gigs of memory, and then you top out. With virtual memory, you can you're running a lot more, using a lot more memory in a sense, but it's only there's only a small amount of that actually being used at a time. So when a process is active, it's alive, it's using that memory, and then any process that is currently sleeping, not executing, its memory is not actually loaded into the physical memory.
I'm confused. Where is the extra space? You can only have if it's not on your disk. Where is it?
It's not on disk. It's in your memory, and it's not that it's using extra space. It's just reusing the space that already exists.
So it's like a form of compression?
No. Multiplexing. So think of it. It's like scheduling, in a sense. It's like how you share think of it how a single core CPU is being shared amongst multiple processes. Likewise,
so
with
you
memory.
have this single bit of memory that's being shared across multiple processes.
Single address space, yes.
You have an address space that has some content that the computer figures out is actually shareable?
Confuses me.
No, not exactly. It's the fact that you have a physical address space that maps to a certain page table. You have a page table that maps a certain virtual address space to a physical
hold on.
address space.
Now, what is a memory page?
A memory page is just this, page table, I should say. Yeah, a memory page is a block of memory. But a page table is what's actually doing the logic there to say that this virtual address space maps to this physical address space.
Okay.
And it's being done in the kernel there. And then you have the kernel itself does these algorithms to reclaim these page tables once a process is no longer being executed. So that way it's not just being used over and over again. You this is done by what's called the paging supervisor that's actually managing these page tables.
I gotcha, but I still don't understand how the same bit of memory could be used.
It's not being used at the same time. It's being shared. Like, think of it like a timeshare.
Across what? If you have if you have a bunch of programs loaded on your computer, and then it's not sharing memory between the programs.
Yeah, it's only being shared, but the currently executing process is actually running has the memory loaded into the physical address space, while the virtual address space is just being used. The page table keeps reference.
How does it know how to multiplex this data together?
Through the page table and the page supervisor.
And how does it figure out that this data needs to be combined with some other data? Because it's the same? And then it says these two.
What do you mean combined with other data?
I don't get how you multiplex this data to create more Like
So,
I guess
address
it's just like
physical
matching
address
matching contents and address spaces. So it's like if address space A has the same content as address space B, then you can say,
No,
actually
that's
these are the
something
same.
else. That's KSM.
Is this RAM or is this memory?
This is RAM, which is memory.
I see how that can work then,
thinking of
because
is
then,
storage.
like, yeah, it's just currently not processing all those processes. I see how that could work.
Right. Yeah. So the page table itself,
It's
you
not
have
holding
n page
stuff
tables
physically
per
in
process.
memory; it's processing stuff.
Oh,
Well.
so just moving stuff in and
you
out
have-
of memory.
Let me put it this way. Think of it: physical address space 0, and then you have several processes. They each have. Let's keep it just for an unrealistically simple case. You have one page table per process. So in process A, the page table, its page table says have an int of 1 point to that physical address space. Page table for this process B says have an int of 3 points to that address space. And then for the next topic to lead into KSM, let's have process C say have an int of 1 point to that address space. Now, when A is running, the thing in physical memory is this int of 1. And when B is running, it's an int of 3. But then when C is running, it's an int of 1. And then through KSM, which I think is what Eric was thinking of, that'll actually say, hey, these two page tables are the same, let's merge them. And then...
that is, yeah, okay. So that's kernel's same page name merging.
Yes.
Okay, that's KSM, not Khalid Sheikh Muhammad.
It was close.
That's another
though.
KSM. Yes.
Mm-hmm.
Anyway, okay. So then I don't get what virtual memory is. I'm
It's what you
so
use.
then
I think, Eric, that like the amount, like say you have 4 gigs, that's like how much power it has to give, but like that doesn't mean how many different things it can process at one time. So you can have like
does
10
the virtual
different
memory
things.
just cycle stuff in and out of the swap space? Is that what it is? No.
No.
It's not what it
It's
is.
the fact that you have in your kernel memory space, there is this concept of page tables.
Wait, is it so all the references could be the same, but then the kernel manages where that actually goes?
Yeah.
Yes?
I think you have it reversed. It's that the references in virtual memory can be different, and they can all go to the same physical address.
Wait.
Can we go next?
No,
the
so
same
the
physical
programs request this. It's that the programs request the same location of memory, but then it actually goes to a different address physically because it's virtualized.
No, that's the reverse.
Why is it the reverse?
All right, let's move on.
Okay, next
All
time.
right.
All right, after virtual memory, we've got all these file systems.
Yeah, which let's start off with the one that's on the surface, the virtual file system, which is just the one that you actually deal with in user space, where you have your blocks and then you have inodes, and then you have the files that are made up of inodes. And so, files can be anything from a plain file to a directory, and there's a few other special ones in there, like devices and blocks themselves. And so then you have devices and blocks can be mounted, and then within there you have these inodes, which are essentially a tree of data. You have each file. You have at its first layer, you have a root inode that is the file that ends up working as the file descriptor and has all of its the basic info on the file, and that points to 12 what are called direct nodes that contain data, and then 3 indirect nodes that can point to either
Where
data
do these numbers
or
come
more
from?
inodes. These are just the set numbers in the kernel. This is how inodes are designed.
What is an inode?
An inode is essentially a pointer in a tree to data of a file.
And why are there these 12, 3... Are they multiples of 3?
The 12 hold actual data, and then you have 3 indirect that... Think of it this way. When you go to write to an actual disk, particularly on a spinning disk, you're not always writing to that same exact spot. You're going to be writing in a further point in the disk.
Right.
And to be able to point to that, you have these indirect ones saying, okay, I have these inodes over here that contain this data. So that way you're traversing a tree instead of having to actually do this lookup.
Oh, okay. Interesting. interesting. And virtual file systems have other uses because you could also use them to bridge the gaps between, let's say, sorry, I need to. I'm not having a good day today. They can be used to bridge gaps between other proprietary file systems, like if you needed something that could read both NTFS and HFS plus.
Right.
You could use a virtualized file system.
A good example is all the file systems that are supported by Linux, whether it be ButterFS is the new hot thing, XFS, ext4fs,
but not
ZFS,
the two that I named.
AFS. Sorry, say that again?
I said not the two that I named, NTFS and HFS plus.
Right,
not out
those
of the box,
are
at least,
proprietary. Although
proprietary.
NTFS, you can use what is that? Samba, something like that.
Samba is for networking.
Yeah, but like for NFS, NTFS.
No. Samba is for NFS.
It's NFS to NTFS though.
You're right. No, but it's not. You can't mount an NTFS disk with Samba. That's just for networking.
No, but a NTFS file system can mount to you with Samba.
Yes, if you share it over a network.
If you're running a say you have a sandbox.
If you're running a Windows computer, you can see your NTFS volume over your from your Linux computer.
No. It's not an NTFS volume there. It's that you have your NTFS drive that's mounted into your Windows machine that then is trying to access a NAS unit or a SAN unit, and that happens to be running Samba because it's a Linux machine, that SAN unit.
Right,
and
Samba networking Windows, not file system type.
It's to allow a local Linux disk be mounted into a Windows system.
Samba?
Yes. Over NFS.
It's the other way around.
No. Well, technically, when you do mount it, you can read and write in either direction. So,
gotcha. So all these file systems, why would you want to use XFS over ZFS over AUFS?
So there's a lot of reasons. Some of them are copy on write. Some of them aren't. Some of them don't have journaling. Some of them do. Some of them structure their inode trees differently. Why would you want something that doesn't
have journaling this day and age?
You'd want that. Which is why certain older file systems
doesn't
aren't
have
around
journaling,
anymore.
Really?
What?
Doesn't have journaling?
No, that do.
That's what I said. I said, why would you want something that doesn't have journaling in this day and age?
You don't. Yeah. I'm saying that's why there's older ones that existed that were supported, but you no longer want to use. Yeah. But ButterFS is this really hot new one that does copy on write. It has this concept of subvolumes. What?
Butter. I said it's hot and smooth. It's hot and smooth, like butter.
Yes, it is. And so that one has the things like subvolumes, which are great for containers. Similarly, AUFS is the classic Docker file system that does these layers, and they can be shared amongst different containers in the mount namespace. And similarly, there's some more basic ones like ext4fs is your more traditional Ubuntu file system. XFS has some read and write optimizations, but it is still not as fancy as ZFS was kind of like a lot of its features were moved over to ButterFS. ZFS originated actually in the world of FreeBSD.
Is there really I wish there was some kind of chart of the best file system to use for whatever distro, because this is really almost.
I bet there's something out there that says hey, this file system has these features and this file system has these, etc.
I'd hope so, because this is almost as overwhelming as starting a JavaScript project in 2017. The amount of differences of I don't really know if I'm going to want AUFS over ZFS for my
basically
random Ubuntu
look at it as
computer.
ButterFS has a lot of these cool features, but it's not stable. And then everything else from there,
anybody, your standard Ubuntu user, why would they want anything over ext4, which is the new standard?
Well, I run ext4, but on LVM, so I have these logical volumes that are actually the things being written to. And those can be resized easily, and
aren't most things logical volumes these days?
Yes, but you can also just say, I just want ext4 on my entire drive, and I don't want to resize it ever.
What would be the advantage of an illogical volume?
You mean just running ext4 or something like that? Where
the whole drive is one giant partition that you can't do anything
It saves
with.
a little space, basically.
A very little space.
Yeah, it's negligible.
Totally worth it.
So no, but again, why would you want anything more than an ext4 for standard Linux use? Or, like, your standard
copy and
Ubuntu
write can be
person?
pretty useful. Where if you have basically the same blocks of data, they're being shared on the file system until they change. At which point, then there is a new one actually being a new inode is created, as opposed to sharing this inode. And similarly, that can be done through layers, where you have the entire file system. Each version is a new layer, and then you say you're doing this through you're namespacing out your mount namespace. For the example, there is containers, and this is the AUFS is what I'm talking about with layers. It's the default Docker file system. Actually, is AUFS. And with that, you can say image. My Redis image shares the Debian layer, which is being shared by my node container. So they both share in the Debian layer instead of having two entire Debian environments on disk.
Gotcha. But if anything like that were really cool enough, wouldn't it just eventually make its way into ext4, into your standard use for consumers?
No, because it's not necessarily the use cases that ext4 is being built for.
I'd like to think that a lot of people would like copy and write.
Yeah, which is why Butterfly is being developed. That's why ZFS.
No, but I'm saying, like,
exists.
for something like that, why can't you just add that to ext4? Because that's the default.
Because that's not something that they're deciding to do. They don't agree with that.
They, as in Linux.
The developers who work on it.
Okay.
Linus said no. Next.
Jeez, Tyler, I'm getting cranky. Namespaces.
I'm just trying to keep the show moving.
We just talked about namespaces. Namespaces are a feature of the Linux kernel that isolate and virtualize system resources as a collection of processes. Examples of resources that can be virtualized include process IDs, host names, user IDs, network access, inter-process communication, and file systems. Namespaces are a fundamental aspect of containers on Linux.
Mm-hmm.
So your namespaces...
This is actually probably one of the more simple constructs in the kernel. This is to say, I have a certain process or just a certain execution context that I want to run isolated from the
marking your territory, basically.
More so saying, not really marking it so much as saying I have this. I don't want this thing to know what PID1 is a good example to say. I'm running a process that it doesn't need to know what PID1 is, or I don't want it to know what PID1 is, or I want to be able to package up just a certain process, so that way I can just basically essentially throw around that process to different servers. That's
so
a very
scoping,
common use.
I guess?
Yeah. Scoping, packaging,
gotcha.
portability.
Hence namespaces. That makes sense. You use namespaces in code and elsewhere all the time. All right. Next is C groups. What is a C group? Wait,
C groups
hold on.
is another...
No, wait. Don't tell me. Wait, don't tell me. It is a Linux kernel feature that limits or accounts for and isolates the resource usage, CPU, memory, disk I/O, network, etc., of a collection of processes. Engineers at Google started work on the feature in 2006 under the name process containers. In late 2007, the nomenclature changed to control groups to avoid confusion caused by the multiple meanings of the term container. Okay. So C groups or control groups is quotas, basically, for processes in the kernel? Quotas set by the kernel for processes?
Sorry, I got ohmed, but I'm back.
Oh, okay. Well, I didn't notice the difference. C groups, they're just quotas for processes established by the kernel, or what is it?
So you have two things. You have quotas, which are saying I need this process or groups of process must have these resources, or it is to do shares to say give me a certain percentage, and then if I can go over if I'm not contested by other processes.
Gotcha. Okay, and then privileges, protection rings, and capability-based security. A lot of the stuff that we've talked about tonight are about the Linux kernel, and we've kind of left out the Windows kernel because it sucks. Yes, thank you very much. But seriously, the Windows kernel has gone through quite a large evolution over the last 20, 30 years. And it used to have this thing called rings, where each type of privilege was within a ring, and the root was ring 0, and it fanned out into ring 1, ring 2, ring 3. So they're called hierarchical protection domains, or rings. Mechanisms to protect data and functionality from faults and malicious behavior, This approach is diametrically opposite to that of capability-based security. So what would happen is, on early Windows, you could say, like, the graphics driver, the graphics library was in ring 0 because it just had to address the hardware directly and didn't really. I don't know if it was for convenience or it was because of resource restriction. They didn't really want to have a more robust system of drawing stuff on the screen, so they just kind of dumped it out into the just wrote it onto the hardware, which required a higher level of privileges than programs typically would have. And then because you do that, of course increases the risk for security exploits and your computer to crash and things to go wrong, because if something in ring 0 has a problem, and it's basically just, I am really off the metaphors today. I don't know. I was trying to not think of something too explicit, but yeah, it's not good. Let's see. Special gates between rings are provided to allow an outer ring to access an inner ring's resources in a predefined manner. Not sexual, yeah. As opposed to arbitrarily allowing usage. Correctly gating access between rings can improve security by preventing programs from one ring or privilege level from misusing resources intended for another. For example, spyware running as a user program in ring 3 should be prevented from turning on a web camera without informing the user, since hardware access should be a ring 1 function used for device drivers. Programs such as web browsers running in higher numbered rings must request access to the network, a resource restricted to a lower number ring. That is, as it said, diametrically opposed to the capability-based security, which I'm adding to. Where is it? I just added up. What is it? What is capability-based security, Christian?
Capability-based security is, say, I have a certain namespace, process, or user in certain cases that can do certain things and can't do certain things. So it's like saying, I think the basic one that isn't really explicitly a capability, but it is the same practice as to say, do I have read-write to this file, or do I have can I execute it, which is using capabilities under the hood, actually, to do so. But another one is to say, can I have access to a network interface, yes or no? And that's a capability.
Gotcha. And that's very similar to the ring negotiation that we talked about, except that this is much more robust and probably much
in fact, if you want to see capabilities in action to really lock things down, I suggest people go to contained.af, and it is a particular developer who has a lot of experience with containers. They made this website that essentially you have a WebSocket session to a bash running in a container, but it is locked down completely, and that's all thanks to Linux capabilities that you just can't really do anything in the container.
Now, I thought you were actually able to break out. You figured out how to get out of the container.
No, but
I don't know if I just know.
You can give them a lot of crap about it by catting dev view random into random files.
Is that... we'll get into that later. A capability is defined to be a protected object reference, which, by virtue of its possession by a user process, grants that process the capability, hence the name, to interact with an object in certain ways. Those ways might include reading data associated with an object, modifying the object, executing the data in the object as a process, and other conceivable access rights. The capability logically consists of a reference that uniquely identifies a particular object and a set of one or more of these rights. And you just gave a great example, which is, can I read-write into this file? And when you open a handler for that read-write privilege, you get a variable, and that variable is a reference, which is the index of a file descriptor in the process's file descriptor table. This file descriptor is a capability. Its existence in the process's file descriptor table is sufficient to know that the process does indeed have legitimate access to the object. Interesting. That seems much more straightforward than these rings. I don't know who thought of these rings.
Some Windows developer.
Yeah, it's like basically that's this is much easier to understand than you get a descriptor, and if that's in the table of the things that can access this file, then it can, and if it's not, then it can't. Not this, ring 1 has to hand off to ring 2 unless it's asked by ring 3. Anyway.
Going down, down, down to the ring of fire.
Capability-based security. Related are access control lists. Access control lists are just a list of things that can access this, but that's not necessarily the same as a capability, although I feel like it could be somehow.
An ACL can use capabilities to enforce itself. And also similarly related is SE Linux and AppArmor. SE Linux is a way of labeling, saying I have an SE Linux user A, and then say that only users of Type A can use a certain capability with SE Linux.
Now, is SE Linux? It's an entirely different distro. It's its own distro of Linux.
It's not a distro. It's a kernel module.
It's an add-on, or it's a what? Sorry,
it's a kernel module that some distros have, some distros don't, and you can add it. And a lot of people definitely complain about it because it makes a lot of things difficult.
Like what?
Which I think is just security in general. It makes things difficult, which is part of its job.
Right. A lot of people don't like having to enter their password after a screensaver. So they make their computer less secure. That's not the solution. All right, but would you advocate people use SE Linux?
Certainly for server situations, yes. It might be a little overkill. I wouldn't say it's actually overkill, but if you're just using like a Chrome OS, actually I think Chrome OS has like a really advanced abstraction around SE Linux that makes it pretty easy. But if you're just running, particularly getting it set up on Ubuntu, it's not exactly easy. But CoreOS and Red Hat are the biggest contributors to it. In fact, they hired the guy who originally created SE Linux over at the NSA, and now he works for Red Hat.
Oh, that's cool. Let's see. Linux kernel security module. You said all that. Its architecture strives to separate enforcement of security decisions from the security policy itself, and streamlines the volume of software change with the security policy enforcement. The latest update also sends your traffic to the NSA. Yeah, that might be why some people have a problem with it. No. Anyway, SE Linux and then AppArmor. Is that another? That's an app that you can use.
No,
another
it's
Linux
it
kernel
kind of goes in
security
conjunction
module.
with SE Linux, though, and it is essentially a profile per app that says this is how I want my capabilities in my SE Linux managed.
Gotcha. So you can use both of them together?
Yeah. In fact, like a really, really secure container are going to use these and raw Linux capabilities in conjunction to lock down the container.
Gotcha. Let's see. I think that's it for the Linux kernel. There are quite a few differences between the Linux kernel and the Windows kernel. But after going through them, it really is a lot of which level is this bit of architecture, and it's in a different level in Linux versus Windows. And then also now there are, I think, 3 distinct Windows kernels between the old, classic, horrible Windows kernel.
There's the DOS. There's the whatever.
No, I didn't even think of DOS. There's like the Win9X kernel. There's the WinNT kernel, which is much more stable. It has better multitasking. Won't have.
Are they on a new one now? Then
there's the MinWin kernel, which they rewrote for Windows 7. Now, MinWin is the smallest standalone bootable, usable segment of Windows 7. In order to get MinWin, Microsoft simply cut components from the Windows operating system to obtain a core which is completely isolated and self-sufficient.
Wasn't the original Windows Phone running Windows 7? And that's probably why they had this?
Yeah. In this sense, there are no dependencies outside of MinWin. Well, I mean, this goes with the whole... I'm sure they've just been adding components onto this piece of software that then got too big, like with Windows, and then they have to rewrite it and modularize it and refactor it, and you end up with something that is much smaller and now is much more componentized. And that kind of fits with the broader message of what they've been doing with Windows since they had the debacle with Windows Vista, where it all exploded halfway 2003, I want to say. That's when they came out with Windows XP Service Pack 2, when they realized back in the Longhorn days, this code base is getting unmanageable, and then it actually became unmanageable, so they had to rewrite it. And that's why Vista took so long. So they did the same thing during that, after they did that, and then they did it to the Windows kernel. So I support this activity, and I believe I saw a video around when this came out, of a virtualized environment that ran the Windows kernel, which was basically a DOS shell, and like 32 megabytes. It's crazy. It's a surprisingly small amount of memory needed to boot up bare Windows these days. Ironically, it needed a lot more memory back when computers had less of it. But that's Microsoft for you.
Who else but Windows?
Do you want to end with a... because it is getting a little long. We're past 90 minutes, and we didn't even do a Where Am I ad. It's okay, we can save that for next week. Do you want to end with a Windows exploit?
Well, is there any other way to end?
Yeah, exactly.
Or how about
Linux
just read off your
exploits are
blue
not
screen
that.
message?
It's from a PowerPoint written by It's a PowerPoint written by some people from Google called "There's a party at Ring Zero and you're invited." And it just talks about executions of all operating systems make some assumption. You know what? We haven't actually. I can't believe we talked for 90 minutes and I didn't go into one of my stupid... where is it? Oh, because I moved all that stuff. That's why. All systems make some assumptions about kernel security. Sometimes a single kernel flaw can break the entire security model. Things like sandboxing in Google Chrome and Android make us even more dependent on kernel security. All right, that's it. So they found a bunch of exploits. Blah, 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 blah. I'm trying to scroll down here. Here's one, Windows 2003 KI raise assertion bug. In Windows Server 2003, Microsoft introduced a new DPL3 that's accessible to Ring 3 code. IDT entry, it's the KI raise assertion. And if you're familiar with the Windows API, which I'm not, you'll know what this means. KI raise assertion in the public symbols, and they have a screenshot here. This makes the raise assertion memory instruction roughly equivalent to the raise exception status assertion failed. Interrupts that were not enabled before the execution dispatch. This would be really funny if I actually knew what this meant. Never mind. Let's see. It's a lot of stuff. Let's see. Windows NT filter token bug. NT filter token is a system service that makes routines like the create restricted token work. NT filter token would pass a void to a helper routine, which would be used to store the captured data. I can force the capture to fail by claiming the SID is bigger than it really is, and forcing the structure to straddle a page boundary. Basically, it's all some really low-level... Really
low-level bad decisions.
Really low-level bad decisions that have to do with how memory is stored in programs and how privileges are handled in programs. And that's really the whole moral of the story. I could read all of the stuff, but it all circles back to that. So
it all comes full circle. Like a ring.
There we go.
Yay!
And on that note, I think we've reached another end to another pull request. So, Christian, do you approve of this week's pull request?
Looks good to me.
Tyler, how about you?
I do.
Well, I've learned a lot about... I was going to say a lot about merging. I've learned a lot about kernels this week, so let's all hit merge. And we'll see you all next week, right here on Polar Quest. This has been a Pneumonium production. The views and opinions expressed on Polar Quest do not necessarily reflect those of Pneumonium, LLC, or its subsidiaries.